Icy moon of Jupiter. It's got this thick icy crust. It's about the size of our moon. It's got this thick icy crust up to 80 miles thick. Underneath that icy crust is 2 to 3 times as much liquid ocean as we have on planet Earth. And so they're very confident there's volcanic activity under that ocean because there shouldn't be liquid ocean that far from the sun, right? And then if you look at the images of Europa itself, they'll come around here and on the poster there, those big fissures, those big cracks in the ice are filled with that orangey red material. They're pretty sure that is the building blocks of life, organic chemistry. And on Earth, when we have organic chemistry plus liquid ocean plus volcanic activity, that is where we find an ecosystem. So this moon has been enticing NASA for over 3 decades. We've been trying to devote a spacecraft to it. So now everyone look in the room and describe what you're seeing. I'm going to talk about the spacecraft from the bottom up. If I talk about the first floor of the scaffolding and the second floor, that makes sense to everyone? Yeah. So if you go to the top of the railing of the second floor, everything below that level on the spacecraft itself, that most of that column is the propulsion unit. And then that box on top with all the instruments sticking out of it, that is the avionics or electronics vault. It's the brains of the spacecraft. And then of course this big jiffy pop on the side that looks like a walk, that is the high gain antenna. Thank you. High gain antenna. It is wrapped, you'll notice this thermal blanketing is not the gold or the dark gray, it's this gray silvery mat, and it is graded for high radiation like Jupiter gives off. This, to answer your question, my friend, this will be at JPL until May. This box structure that's right in front of me right here, you'll notice a ring at the bottom of it. You'll notice underneath the thrusters of the actual spacecraft also has a ring. That's basically how they move it around. They're going to take it from this structure and put it in this, and then they're going to wheel it up the mountain in a sealed container. Because it's about to go to our thermal vacuum chamber. So if you come here in a couple weeks, you won't see a spacecraft, and I'll be giving a tour of a bunch of ladders. So good job on the time. It's always rough when there's no spacecraft in here. It's going to be at JPL till May of this year. There's a 24-hour webcam. You can check it. Now that you're good friends with it, you can check in on it anytime you want to see its progress. It'll be in and out of this room until May. We package it all up in a very secure, sort of airtight container. There's a great time-lapse video on how we get a spacecraft from this facility to our clean room in Florida without letting it touch the air, basically. And then it's a military escort down to Florida in May. It has about 6 months of final assembly and testing. And then it is the launch window opens October of this year. October 2024. It's a 3.5-week launch window. Excuse me. If we miss the launch window, we have to wait 13 months. So we're not going to miss that launch window, you better believe. It'll take 5.5 years to get out to Europa and Jupiter. And then it will be April of 2030. And then it will start a 2-year initial mission. It's looking for signs of habitability. That's its big mission. What questions can I answer about anything?
What's our friend Elon Musk going to do?
Well,